So welcome friends. Today we are going to study the titration curve for strong acid and weak base. Titration curve means it is a plot of pH versus ml of titrant added. Okay, is called as a titration curve. Now let us consider the titration curve the titration between strong acid and weak base. Okay, what is a strong? Strong means okay, any acid or base which dissociates completely is called as a strong acid or a base. Weak, it dissociates partly. Here in this titration, we are using ammonium hydroxide as a weak base and HCl as a strong acid. Okay, the concentration of both is 0.1 molar. The dissociation constant of weak base ammonium hydroxide NH4OH is shown by letter Kb. It is equal to 1.75 into 10 raised to minus 5. Now, when we titrate strong versus weak, then in that case, strong electrolyte is taken in a burette and weak electrolyte is taken in a conical flask. Strong is taken in a burette and weak is taken in a conical flask. Okay. Here, weak base is a titer and strong acid is a titrant. Okay, strong acid is a titrant. Okay, remember this T. Okay, hint, this T stands for burette. Okay, titrant, solution which is filled in burette, which is used to titrate against another solution is called as a titrant. Okay, titrant, the solution whose concentration is to be determined is called as a titer, and this is present in the conical flask. Now, let us consider 25 ml of 0.1 molar ammonium hydroxide solution. Okay, let us take this solution by pipette in a conical flask and fill burette with 0.1 molar HCl solution. Okay, now let us calculate pH of the solution at different stages of the titration. First, pH at the start of titrations. Okay, so at the start there is only 25 ml of 0.1 molar ammonium hydroxide present in the conical flask. Ammonium hydroxide is a weak base and its dissociation is a less. Okay, so this is ammonium hydroxide. When it dissociate, it forms NH4 plus and OH minus. So initially, before dissociation, the concentration of ammonium hydroxide will be 0.1 and this ammonium ion and hydroxyl ion will be 0. Okay, why? Because this is the initial concentration before dissociation. After a certain time, what will happen? Some amount of ammonium hydroxide will get dissociated into NH4 plus and OH minus ions. So, and there will be equilibrium formation. So, at equilibrium, the concentration will be, let's say X is the concentration of NH4 plus ion and X is the OH minus ion. So therefore remaining concentration of NH4OH minus NH4OH will be 0.1 minus X. Okay, so at equilibrium, according to the law of mass action, therefore Kb, okay, capital Kb is equal to concentration of product upon concentration of the reactant. So here product is NH4 plus and OH minus and reactant is NH4OH, and this Kb, capital K at the suffix B, is dissociation constant of weak base NH4OH ammonium hydroxide, and its value is 1.75 into 10 raised to minus 5. Okay, so same value is for weak acid also. Weak acid, acetic acid, 1.75 into 10 raised to minus 5. Now let us put the value of concentration at the equilibrium. So it will be, okay, value of ammonium hydroxide at equilibrium is X, OH minus is X, and that of NH4OH is 0.1 minus X. Okay, so it will be X square upon 0.1 minus X. So let us simplify this equation for the X. Now in this case, the concentration of NH4 plus and OH minus ion is very less. Therefore, the difference 0.1 minus X is nearly equal to 0.1. Put this value in this equation, then we get Kb is equal to x square upon 0.1. Okay, so let us simplify this. Therefore, x square is equal to Kb into 0.1. So let us put the value of Kb. It is 1.75 into 10 raised to minus 5 into 0.1, and this 0.1 we can write as 10 raised to minus 1. So final answer will be 1.75 into 10 raised to minus 6 molar. Okay, so take square root of this term, x square equal to this much, so therefore x is equal to square root of this, and it will be 1.328 into 10 raised to minus 3, right? And this x is nothing but the concentration of OH minus ion, which is equal to 1.328 into 10 raised to minus 3 molar. Okay, now we have got, or we have calculated the concentration of OH minus ion, and from this value let us calculate the value of pH. How to calculate value of pH? So from OH minus ion concentration, find out pOH, and then use the formula pH plus pOH is equal to 14. Adjust the formula and find out the pH of the solution. So what will be the pOH value? What is formula of pOH? pOH is equal to negative log of OH minus ion. Just put this value in this formula. Negative log of 1.328 into 10 raised to minus 3. Simplifying this, then we get 2.8817. Okay, this is the value of pOH. So therefore, pH plus pOH is equal to 14. pH is equal to 14 minus pOH. Put this value of pOH in this formula. Then we get pH is equal to 11.12. Right. So therefore, pH at the start of titration is 11.12. pH at the start of titration is 11.12. Okay. Now, what will be the pH after addition of 1 ml of strong acid in 25 ml of strong weak base solution? Let us calculate that. pH after addition of 1 ml of 0.1 molar HCl in 25 ml of 0.1 molar ammonium hydroxide solution. Okay, so when 1 ml of 0.1 molar HCl is added to the weak base solution, it reacts with 1 ml base solution and it forms a basic buffer solution. Okay, in previous lecture, okay, the titration between strong acid and weak base, okay, acidic buffer solution was formed. Here basic buffer solution is formed. Okay, the total volume of solution becomes 25 plus 1 is equal to 26 ml. What will be the reaction? The reaction between NaOH, sorry, here is the HCl and this HCl and ammonium hydroxide is, so ammonium hydroxide is a weak base and HCl is a strong acid. Okay, just neglect this, here it is printing mistake. NH4OH and HCl, it will form ammonium chloride. This is a salt and water. Okay, so this is the basic buffer solution is formed here. Now the concentration of basic buffer solution is calculated by using the formula, and this formula is known as Henderson equation. So therefore, concentration of OH minus is equal to Kb times ratio of concentration of base upon concentration of the salt. Okay, now let us calculate concentration of the here base. Okay, concentration of the base. So concentration of old base is equal to concentration of the new base. Okay, here it will be base liya. Here is not the acid, here is the base. Concentration of old base is equal to concentration of the new base. Therefore, N1 V1 equal to N2 V2. So what will the old base concentration? When you add 1 ml of 0.1 molar HCl solution, then this 1 ml will react with 1 ml of base solution. So total volume remaining will be 25 minus 1. Okay, so old concentration is 0.1, remaining volume will be 25 minus 1. This is the old concentration of the base. New concentration, okay, that we are going to calculate. So resultant volume will be 25 plus 1. So it will be 0.1 into 24, which is equal to N2 into 26. So simplify this, then we get, therefore N2 equal to 0.1 into 24 upon 26. Okay, just rearranging this equation. Okay, I am taking this 26 to the left hand side. Okay, therefore N2 equal to 0.1 into 24 upon 26. Now simplify this. Okay, if we simplify this, then we get concentration of N2, okay, equal to 0.09230 molar. Okay, therefore base concentration will be this much. Okay, here. Now let us calculate the concentration of the salt. Okay, so आता इथे salt किती तयार होईल? Okay, how many millimoles of salt will be formed? Okay, so zero point 0.1 molar 1 ml weak base reacts with 0 0.1 molar 1 ml of acid, strong acid, and it will form 0.1 molar 1 ml of the salt. So millimole will be 0.1 into 1, right? So the formula, concentration of salt is equal to millimoles of salt formed divided by total volume of solution in ml. Okay, so millimoles form will be zero point 0.1 into 1 divided by 25 plus 1. So this is the total volume of the solution. If we divide it, then we get the answer 0.003846 molar. Okay, now let us put this for a value of base and salt. Okay, concentration of base and concentration of salt in this formula, then therefore we get concentration of OH minus is equal to Kb into concentration of base upon salt. Okay, here is the base, you can correct that. Okay, so which is equal to 1.75 into 10 raised to minus 5. Put the value of base and value of salt here, simplify this, then we get, so division of these two term is 24, and 24 into this equal to 42.00 into 10 raised to minus 5 molar, or 0.4 times 0 42, sorry, 3 times 0 42 molar. Okay, this is the concentration of OH minus ion. So from OH minus ion, let us calculate POH, and POH formula is POH is equal to negative log of OH minus ion concentration. So put this value, negative log of 42 into 10 raised to minus 5. Okay, let us find out log, then we will get POH value is 3.3767. This is the value of POH. Now pH value is, pH is equal to 14 minus POH, which is equal to 14 minus this POH 3.3767, which is equal to 10.62. So therefore pH after addition of 1 ml of HCl is 10.62 unit. Okay, this is the pH. Okay, now let us calculate pH after addition of 2 ml of 0.1 molar HCl in a 25 ml of 0.1 molar NH4OH solution. Okay, so when we add 2 ml 0.1 molar HCl, it will reacts with 2 ml of 0.1 molar basic solution, and it will form basic buffer solution. The total volume will be 27 ml. Okay, and the concentration is calculated by using the formula, concentration of OH minus is equal to Kb into concentration of base upon concentration of the salt. Okay. So concentration of base is calculated by using formula, concentration of old base is equal to concentration of the new base. N1 V1 equal to N2 V2. Here V1 will V1 equal to 25 minus 2, V2 equal to 25 plus 2. Okay, simplify this, then we get N2 equal to 0.008518 molar. So this is the concentration of our base. Now let us calculate concentration of the salt. Okay, so how much salt is formed? 2 ml of 0.1 molar base is reacting with 2 ml of 0.1 molar acid, hence it will form 2 ml of 0.1 molar salt. Okay, so the concentration of salt is equal to millimoles of salt form is equal to total volume in ml of the solution. So millimoles किती तयार होतील 0.1 into 2 divided by 25 plus 2. Okay, do this division, then we will get 0.007407. This is the concentration of salt. Okay, so put this value of concentration of salt and concentration of base in the standard Anderson equation. OH minus equal to Kb into concentration of base upon salt. Okay, simply put the value of Kb, base and salt, then we get concentration of OH minus is equal to 20.12 into 10 raised to minus 5 molar. Okay, 20.12 into 10 raised to minus 5 molar. So therefore POH is equal to 3.6962. POH is equal to 3.6962, and hence pH will be 14 minus 3.6962, which is equal to 10.3. Okay, so this is the pH after addition of 2 ml of HCl. Okay, so for the 3 ml addition of HCl, the pH will be 10.11. Okay, similarly if we go on adding 4 ml, 5 ml, 6 ml up to 24.55, then pH decreases. Here you can see the decrease in the pH value. Okay, so here pH value is 7.55. Now let us calculate pH at the equivalence point. Means when 25 ml of 0.1 molar HCl solution is added to the 25 ml of 0.1 molar basic solution, then what will be the pH of the solution? Okay, what is equivalence point? The point at which equivalent quantities of acid and base reacts together is called as equivalence point. Okay, so at equivalence point all acid reacts with base and only salts remain in the solution. At equivalence point all acid reacts with base and only salts remain in the solution. So what happens? This ammonium hydroxide reacts with HCl and it is forming salts. So how many millimoles are formed? So 2.5 millimoles of base reacts with 2.5 millimoles of acid. So equivalent quantities are reacting together. Okay, and this point is called as the equivalence point. This point we call this as a equivalence point. Now at equivalence point the concentration of salt formed is equal to millimoles of salt formed divided by total volume of the solution. So volume of solution will be 50 and millimoles of salt will be 2.5. Its value will be 0.05 molar. Okay, so pH at the equivalence point can be calculated by using the formula. This is the formula. pH is equal to 1 half pKw, okay, minus 1 half pKb minus 1 half log C, and here log C is equal to concentration of the salt. Okay, pKw is equal to negative log of Kw. Kw means ionic product of water. pKb is equal to negative log of Kb. Kb is our equilibrium constant for base or dissociation constant of a base, and C stands for the concentration of salt. So let us put the value of pKw, Kb and C in this formula, and then we get, therefore pH is equal to 1 half log of Kw value is 1 into 10 raised to minus 14, Kb value is 1.75 into 10 raised to minus 5, and C is equal to 0.005. Okay, so let us simplify it, then we get, so negative log of this term is 14, this term is 4.7569, and log of 0.05 is equal to minus 1.3010. Simplifying this, then we get 7 minus 2.37 plus 0.6505, so its value is 5.272. So Therefore, pH equivalence point is 5.272. Okay. Now let us move ahead. What will the pH after addition of 26 ml of 0.1 molar HCl solution in a 25 ml of 0.1 molar basic solution, weak base solution? So when 26 ml of 0.1 molar HCl is added to the weak base solution, then all base solution gets neutralized. Hence, only 1 ml of 0.1 molar HCl will remain unreacted. Okay, it means that solution will become now acidic. Therefore, the concentration of resultant solution will be millimoles of H plus upon total volume in ml. So millimoles of H plus, millimoles of acid added minus millimoles of base taken divided by total volume. So I am adding 26 ml of 0.1 molar HCl. So 0.1 into 26, and out of this 25 ml will react with 25 ml of base solution. So 0.1 into 25. So millimoles of H plus remaining will be 2.6 minus 2.5 equal to 0.1, and total volume will be 26 plus 25 equal to 51. Okay, so do this division, then we get concentration of H plus is equal to 0.001960. Okay, so from that the pH of solution will be, therefore pH equal to negative log of H plus ions. Okay, put this value of H plus in this formula, then we get pH equal to 2.7077. Okay, so therefore pH after addition of 26 ml of 0.1 molar HCl is 2.708. 2.708. Okay, now so pH after addition 20 ml will be 2.415, 28 it will be 2.247, 29 2.130. So up to 37 ml. Okay, if I go on adding up to 37 ml, then pH of solution will be at 37 ml 1.713. So here pH is decreasing. That means solution is becoming more acidic. Okay, more acidic. So at the end, at this point, my solution is a strongly acidic in nature. Now let us plot the titration curve for this strong acid versus weak base. So to plot, what we need all the values of ml of acid added versus pH of the solution. Okay, so pH versus ml of titrant added. So pH versus ml of titrant plot is like this. Okay, so at the start pH is around 11 pH, and then here is slight inflection, then slow and linear decrease up to the 24.5 ml. Then there is a sharp vertical line around pH change at equivalence point, so around 25 ml, and then slowly again pH becomes linear and steady. Okay, now let us go ahead. Characteristic of titration curve for weak acid and strong base. What will be the characteristics? Okay, first point, pH at the start of titration is 11. Okay, here pH at the start of titration is 11. There is slight bend at the start of titration. Okay, here at this point there is slight bend or inflection at the start of the titration. Third point, pH decreases bit rapidly with addition of HCl up to 24.50 ml, and this change is linear. Okay, up to this ml pH decreases rapidly with linear variation. Fourth point, there is a sharp and vertical change in pH in the volume range 24.55 to 25.55, here in this range. Okay, this is a sharp and vertical change. Fifth point, The vertical part of titration curve, that is pH change near equivalence point, covers approximately 3 to 8 pH units. Okay, हा जो vertical part आहे, okay, this vertical region covers pH change around 3. Okay, this point 3 to 8 pH unit. 3 to 8 pH units. Now pH at equivalence point is 5.27. Okay, so at this 20 point, at this point pH is 5.27, 25 ml, pH is 5.27 ml, and this is called as the equivalence point. After 25.1 ml addition of HCl, pH change is small and it is linear, and this is the part. Okay, this is the point number 7. Okay, now what will be the indicator for this titrations? So the suitable indicator for this titration are methyl orange. Okay, its transition range is 3.1 to 4.4, methyl red 4.2 to 6.3, bromothymol blue 6.0 to 7.6, and phenolphthalein is 8.3 to 10. Okay, so out of this four indicator, the best indicator will be, so the suitable indicator methyl red, okay, has transition range around the pH at equivalence point. Therefore, it is called as best indicator for the titration of weak base and strong acid. Okay, so at equivalence point our pH is 5.25, and this methyl red, it has transition range around 4.2 to 6.3. Okay, so this transition range is around the pH at equivalence point. So from this point 4.2 to 6.3. Okay, therefore this indicator is a best indicator. Okay, all suitable indicator are not best indicator, but a best indicator is always a suitable indicator. Best indicator is always a suitable indicator. Okay, so this is our fourth topic. Third, I think this is our second titration. Second titration आहे ना आपलं